And now you're live. All right. Hello, everyone. We're going to start now. We're going to talk about section 9.6. I'm going to let you see what we are going to do today. All right. Hope everything's doing well. We're having some issues. All right. Seems like it's now. So I was telling you that we talked about this last time just a little bit because someone made a question about it. So yeah, let me explain what it means, and then we're going to go back to this inverse trig ratio. 6 items to know from these figures, right? We have B and C, and then we have the corresponding. Let's better do this because we usually label the hypotenuse as C. And if this is B, this is B, and if this is A, this is A. All right. So when we talk about solving a right triangle, this is what happens. Just by the definition of right triangle, if we want to know 6 things, when I say right triangle, it means that I already know one thing. It means that one of the interior angles is 90 degrees. That means that solving a right triangle implies that I need to find out that I need to know and I need to report these 5 measures. That's it. That's what it means, solving a right triangle. And I will, when we get back to it, I will let you know what are the 2 conditions that have to be satisfied. I mean, either one or the other, okay? So let's talk a little bit about inverse trigonometric ratios, okay? And I'm going to use this right triangle now, okay? So we talk about this, okay, about solving a right triangle. Sorry, about the inverse trig ratios. This is what happens sometimes, and I'm going to use the following measures. And I have to specify that this is a not to scale triangle because this is what I'm going to do, okay? We have a 12 here, a 5 here, and a 13 here. All right. And this is obviously, not what we would expect, but also what we want to find out is the measure of the angles A and B. But we don't have them, but we can find a way, or we have a way to find them. Okay. So this is how it works. Let's first remember how we set up the trig ratios in here, okay? So we can say certain things. If I am standing on angle A, for example, I can say that tangent of A, and by the definition, tangent, so I would say that tangent of A is 12 over 5, correct? Then I can also say, and let's continue with the other 2, and hopefully you are doing that from home as well. I could say that sine of A, and by definition, sine is opposite divided by the hypotenuse. It means the sine is going to be 12 over 13. And finally, cosine of A, and by definition, we say that cosine is adjacent divided by hypotenuse. The adjacent here is 5. Hypotenuse, oh my bad, it's 13. Okay, that's what happens. Okay, the thing is, yeah, I know tangent, sine, cosine, but do we know the angle? That's the point. Okay, we don't know it. So know a certain value, and if it is set up in an equation, we can do the opposite processes in order for us to find out the measure of A, okay, which we don't know yet. We can use any of this and solving for A. So if I use this first equation here, okay, and I'm going to bring it right here, okay, of tangent, which is called inverse tangent, okay? If I were going to do it here, I would use the inverse operation of sine, which is inverse sine, And same thing here. I would apply on both sides inverse cosine. Some people use this like that. So look at this. Let's say that as I go from here to here, now A is solved for, and then I am going to apply this. This is what we call inverse tangent, which in this case, it's inverse tangent applied to 12/5. Okay, usually do is pressing the blue button of the second function and then tangent, which will immediately activate the inverse tangent option. If you are using internet and you are working on Canvas and everything, I would suggest you do this. In Google, you can do this. The thing is that there is another way for us to know or to label the inverse tangent, okay? It is also known as arc, just like that. So we have arc tangent, arc sine, arc cosine, okay? So if you Google that, if you use Google Calculator, what you're going to do is you're going to type this, whatever value you want to find out, in this case, 12/5, yes, just like that. Google is going to give you in return the value of the angle, but in radians, which is a different unit. It's very important for you to type it this way. Hopefully you have just done it for this exercise. I'm going to do it because I am doing it. I'm going to type this on Google, all right? So you do this on Google, you say arc. Oh, wait a minute. I'm going to send it to your arc tangent of, in this case, 12/5. And then, hey, Google, I need it in degrees. This is what I'm going to ask Google to do, okay? So it's on your chat box, it's in your chat box. So this is what I'm going to do here in Google as well. And when I do that in Google, it's going to give me in return this value, 67.4, okay? Degrees. The thing is, let's just report one decimal place. So you have 67.3801350. That's 22.6. Let's just confirm that it's going to be 22.6 using any of the inverse trig. Let's see. For B, we can set this up like this way. We can say let's use inverse sine, for example. So is equal to, remember, by definition, sine of B is opposite divided by hypotenuse. So if I'm here, the opposite is 5, the hypotenuse is 13. Inverse sine of this number, 5/13. And that is going to be equal to what? Okay. Remember, you're going to do that on Google. So this is what you're going to do. Arc sine, inside a parenthesis, you write 5/13, and you ask Google to, hey, Google, I want this in degrees. Don't forget about this, because if you don't, okay, of 5/13, 5/13 in degrees. Thank you. And now it's 22 inverse trig ratios. Okay. As usual, remember to type your questions if you have any on chat box. By the way, what I'm going to do is, oh yeah, I'm going to solve this exercise. I forgot to. Okay, so solving a right triangle. So look at this. Remember, we need to find those 5 values because we already know that one of the angles is 90. So that's the 6th. And this is the angle we need to solve now. All right, look at this. We have 21 here, 20 here. This is F. This is E. This is D. Okay. So solving the right triangle means that I need to find hypotenuse, and we need to find angles E and D. Okay, that's it pretty much. So I'm gonna start finding out what the hypotenuse is, and I use the Pythagorean theorem, all right? Which means that if I want to find this one, right, it means that C is equal to square root of 20 squared plus 1. And when you add them, you get 841. And you take the square root of this, you're going to get a 29. So we're good. Okay, found it. Now, it's up to you. Either you want to find D or E. Let's say that I'm going to try to find E first. So angle E. Okay, and let's use cosine. All right. So I can say that cosine of E is equal to, cosine is, remember, adjacent divided by hypotenuse. For E, adjacent is 21 and hypotenuse is 29. So it's 21 over 29. That means that angle E is equal to inverse cosine of 21 over 29, right? And then this means that you will have to type this on Google, and cosine of 29 over 29, well, inverse cosine of 29 over 29, that is going to be is, okay, you can do this, 90 minus 43.6, and that equals 46.4, okay? Those who are asking, where did you get this 90 minus stuff? Remember that D and E are and this is a time when I stop in class and then I have you do a bunch of exercises and then I go on a one-on-one approach, remember? So, I don't know. That's it. So simple, right? You might be asking, hey, now we're done. What is going to happen? This is what is going to happen. Today, probably during the afternoon, you will see the next two quizzes. 9.4 and 9.5 are going to be together in one quiz. 9.6 is a different quiz, this topic. Then I am going to prepare a practice test. And also, we are going to have a test, okay? That's going to be posted on this. And now you know how to do the lessons and do the quizzes, and please keep working on big ideas math as well. So that's it. That's it, guys. So I'm gonna be here. I'm going to stop the in the stream on YouTube. So the YouTube ones, goodbye. So for you guys